So in this video here, we're going to continue solving for trig ratios if we're given one trig ratio. So in the last video, we learned how to get all 6 trig ratios by building a triangle and finding all the sides. So first off, this one's a little different because you start off with a secant rather than like the original cosine, sine, and tangent. So this one here is what we call a reciprocal trig identity because it is secant is the reciprocal of cosine. So if you need a refresher here, when you have sine, it is the reciprocal of cosecant, and cosine is the reciprocal of secant, and tangent is the reciprocal to cotangent. And last time we talked, we also mentioned Sohcahtoa, so that might help us out here. So I like to write Sohcahtoa so I can remember the order of the trig ratios. So this one here is just a 2 secant is equal to 2. This here, this weird fish-looking shape is just a symbol we use to describe an angle. It's just alpha, but just to get you used to seeing all these Greek letters that we use to symbolize angles. So I'm going to draw a right triangle, and I'll put my angle here, alpha. So from here, I need to see, do I have any lengths to put down? First of all, I need to understand what exactly is secant represent. Well, secant, like we said before, is a reciprocal of cosine. Cosine is adjacent over hypotenuse. Okay, so that means that secant has to be the flip of that. Secant is hypotenuse over adjacent instead of adjacent first and then hypotenuse. Now, another thing I want to mention is that generally ratios are represented as a fraction. This 2 is not a fraction, but we can force it to be a fraction by putting it over 1. So that's how I can be a little bit sneaky there and allow me to draw a better picture of this triangle. So what I know is that the hypotenuse is 2. So I'm going to put down 2 here. The adjacent part, which would be this side here, is 1. So what I don't know is the opposite side. And to figure out the opposite side here is just to use the Pythagorean Theorem. So I would take the 2 legs. Let's call this missing side here, I don't know, x. So in this case, I would take 1 and square that with x and square that. So 1 squared plus x squared equals my hypotenuse squared, so 2 squared. And so from here, I'm just solving it out. This would be 4. I would subtract the 1 over, so this would be x squared equals 3. Take a square root of 3 to get rid of the 2. So this is the square root of 3. So my x here is the square root of 3. All right, once I have all sides, I can build all 6 of my trig ratios. Now, I already have secant, so I need 5 more. So first off, I'll just use sine first. So sine here, I keep using theta, but this should be an alpha because our angle here is an alpha. So sine alpha is going to be opposite over hypotenuse. So sine is opposite over hypotenuse. So that's going to be square root of 3 over 2. And I have my sine. Next is cosine. So I'm just going the typical order, which is adjacent over hypotenuse. So my adjacent here is a 1, and my hypotenuse is 2. So 1 over 2, that's a nice clean problem. Next is going to be tangent. So tangent is toa, or opposite over adjacent. So O over A, and O here is square root of 3, and A here is 1, or in other words, 1 over anything is just going to be itself, so square root of 3. All right, next one here. So we have secant, we don't have cosecant, so let's write that down. So cosecant is the reciprocal of sine. So I have to take sine, which is opposite over hypotenuse, and flip it. So this would end up being h over o, right? Because it's sine that's flipped. And so from here, this would be 2 over the square root of 3. But if a root is in the denominator, I have to multiply the top and bottom by that same root. And so this is going to be 3 on the bottom. Square root times square root is a positive number. So then I have 2 square root of 3 on the top. Now I can't reduce 2 and 3, so this is left as it is. And next part here is cotangent. Oh, I keep writing a theta. My bad, guys. This should really be an alpha. Cotangent is going to be the opposite or the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is going to be adjacent over, oh, I guess I don't have to write it all out, but adjacent over opposite. So in this case here, my adjacent is 1, my opposite is the square root of 3. So again, I can't have a square root in the denominator, so I'm going to have to multiply the square root of 3 to top and bottom. And then from here, if I multiply straight across, that's a square root of 3. If I multiply a square root of 3 with a square root of 3, I get a positive 3. And this here is my final answer. And now I have all five trig functions. So 1, 2, 3, 4, 5, sine, cosine, tangent, cosecant, cotangent, and secant that they gave us. And that's it, guys. Hope you found this helpful. Bye.